Welcome to KT Study Zone. In this video series, we're going to discuss about the motion in a straight line. This is part 1 and we will talk about physical quantities. This lesson is going to be so much interesting. Alright, let's get in. There are two types of physical quantities. First one is scalar quantities. They only have a magnitude. For example, distance, speed, and time. Other one is vector quantities. They have both magnitude and direction. For example, displacement, velocity, acceleration, and deceleration. We will discuss about them in detail. Distance. Well, this is the change of position or the path from one point to another. So basically, this depends on the path we choose. For example, as indicated in the second picture, when we travel from the house to school, we can directly travel, or we can travel through the forest, or we can travel through the cinema. In each case, the distance differs. Well, this is a scalar quantity, which means this only have a magnitude and we do not consider a direction. Displacement. Well, this is the position from one point to another in a particular direction. So in this case, we have to consider the direction. Or in other words, we can say this is the shortest distance between 2 points. For example, if we consider the second picture, to get from point A to point C, the shortest distance is 5 meters. Well, this is a vector quantity. Okay, let's get into example questions. First one. A child starts from point A and walks 40 meters to east until he reaches point B. And from point B, he walks 30 meters to the north to reach point C. So they ask, what is the total distance traveled by the child? So in this case, we have to add separate distances, which is 40 meters plus 30 meters. So it is equal to 70 meters. Second question, they ask, what is the displacement? So, in this case, we have to find the direct distance from A to C. So, I combine point A and point C. In this particular case, this is a right-angled triangle. So, in order to find the magnitude of the hypotenuse, which is AC side, I use the Pythagoras equation, which is AB squared plus BC squared equals AC squared. So, AC equals the square root of 40 squared plus 30 squared in meters. So, the answer is 40 squared is 1600 meters and 30 squared is 900 meters, which add up to 2500 meters. And when we take the square root of it, it is 50 meters. I hope you got that. Second question. A man starts from point X and walks 100 meters until he reaches point Y. Then he walks 60 meters back to reach point Z. First they ask, what is the total distance traveled by the man? So we have to add up the separate distances, which is 100 meters plus 60 meters, which is equal to 160 meters. Then they ask, what is the displacement? In the case of displacement, we have to consider the direction. So, first the man travels in the positive direction, and when he turns back, we have to consider that distance as negative. So, 100 meters minus 60 meters equals 40 meters. Then they ask, if he continues walking and reach back to point Z, what is the total distance now? So, as always, we don't consider the direction, we only consider the magnitude. So, in this case, 100 meters plus 60 meters plus 40 meters equals 200 meters. And next they ask, what is the displacement now? Alright, so we have to consider the direction again, which is 100 meters minus 60 meters minus 40 meters, which is equal to 0. So we can get a point if an object returns to the original point. Then the displacement would be 0. Alright, now we will see about the speed. Well, this is the rate of change of distance or the distance travelled in a unit time. Well, this is a scalar quantity, which means this does not have a direction, only have a magnitude. The equation is speed equals distance divided by time. Example questions. A child walks 40 meters within 10 seconds. What is the speed of the child? Well, we apply the equation speed equals distance divided by time, which is 40 meters divided by 10 seconds. The answer is 4 meters per second. Now we'll see about mean or average speed. When an object does not travel with a uniform speed, it is useful to calculate the mean speed or the average speed during a given time interval. So, the equation is average speed equals total distance traveled divided by total time. Example questions. A child walks first 40 meters within 10 seconds, next 60 meters within 6 seconds, and last 50 meters within 9 seconds. What is his mean speed? So for our convenience, I have plotted the details in a graph, as you can see. So, when we find the mean speed, we can apply the equation total distance divided by total time. So, in this case, 40 meters plus 60 meters plus 50 meters, which is 150 meters, divided by 10 seconds plus 6 seconds plus 9 seconds, which is 25 seconds. And the answer is 6 meters per second. Easy, right? Great. Now we will see about the velocity. Well, this is the rate of change of displacement, or the displacement travels in a unit time. This is a vector quantity, so it is important to note that we have to consider the direction. So, the equation can be given as velocity equals displacement divided by time. Example questions. A child walks 80 meters within 5 seconds. What is the velocity of the child? Well, we apply the equation velocity equals displacement divided by time, which is 80 meters divided by 5 seconds. The answer is 16 meters per second. Constant or uniform velocity. When a body is moving at the same unchanged velocity, we say that it has a constant or uniform velocity. Well, neither the magnitude nor the direction of the velocity changes with time. So, for example, as you can see in this table, the displacement at the first second is 2 meters and the displacement at second is 4 meters and the displacement third second is 6 meters. So, you can see in each second only 2 meters have been moved by the object. So, we can say the velocity is unchanged, which is 2 meters per second. So, we can say the object has a constant velocity. Mean or average velocity. When an object does not travel with a uniform velocity, we calculate the mean velocity during a given time interval. So, the equation is total displacement divided by total time. Easy, right? Example questions. Jack walks first 40 meters within 10 seconds, next 60 meters within 6 seconds, and last 100 meters within 9 seconds. What is his mean velocity? So, we apply the equation mean velocity equals total displacement divided by total time. You can see the details in this graph. So, the equation comes like 40 meters plus 60 meters plus 100 meters, which is 200 meters, divided by 10 seconds plus 6 seconds plus 9 seconds, which is 25 seconds. So, the answer is 8 meters per second. Acceleration. Acceleration is the rate of change of velocity. or the change in velocity per unit time is acceleration. So, this is a vector quantity, as you know. The equation for acceleration is the change in velocity, which is final velocity minus initial velocity divided by time. Example questions. A car starts at rest and accelerates to a velocity of 90 meters per second within 30 seconds. What is the acceleration? So, acceleration equals final velocity minus initial velocity over time, which is 90 meters per second minus 0 meters per second divided by 30 seconds. The answer is 3 meters per square second. In order to find the displacement of a body moving at a uniform acceleration, we should find the mean velocity and multiply it by time. So, mean velocity equals final velocity plus initial velocity divided by 2. So, we can apply it here. Displacement equals final velocity plus initial velocity divided by 2 multiplied by time. You might get a little confused that earlier the mean velocity formula was different, but in that case we did not have acceleration, but in this case we have a uniform acceleration. Example questions. A body starts from rest, is subjected to a uniform acceleration for 6 seconds, after which it acquires a velocity of 12 meters per second. They ask, what is the displacement of the body? So, displacement equals mean velocity multiplied by time, which is final velocity plus initial velocity divided by 2 multiplied by time. So, we apply 0 plus 12 divided by 2 in meters per second multiplied by 6 seconds. So, the answer is 36 meters. Hope it is clear. Next up is deceleration. If the velocity is decreasing, the acceleration takes a negative value. So, this negative acceleration is called as deceleration. This is a vector quantity. Equation is deceleration equals minus acceleration. So, what you have to do is just remember the equation of acceleration and make it negative. Easy, right? So, we can say deceleration equals the minus value of final velocity minus initial velocity divided by time. Example questions. A car moves with a uniform velocity of 60 meters per second, decelerates and comes to rest within 20 seconds. What is the deceleration of the car? So, what we have to do is find the acceleration first. Acceleration equals final velocity minus initial velocity divided by time. So, which is 0 minus 60 meters per second divided by 20 seconds, which is minus 3 meters per second. So, just take the minus value of that, which is positive 3 meters per second. So, the deceleration is 3 meters per second. Hope it is clear. Finally, we'll see what is gravitational acceleration is. When a body falls, its velocity gradually increases or accelerates due to the gravitational force exerted by the Earth. So, acceleration caused by this Earth's gravitational attraction is called the gravitational acceleration. Well, the symbol is g. The average value for g at sea level is about 9.8 meters per square second. Easy, right? That's it. I hope you enjoyed and understood the lesson. All you need to do is practice more questions and subscribe, okay?